Welcome to this explainer. Today, we're unpacking a massive, fundamental paradigm shift in data architecture. Literally, if you work with data at all, what we're about to cover could completely change how your engineering team operates, right from the ground up. So, I want you to just imagine something for a second. Imagine getting sub-second latency on massive data sets, but with absolutely zero infrastructure overhead. And we're talking about a mere fraction of your usual cloud costs. No more agonizing over cluster sizes, no more tweaking node configurations just to run a basic analytical query. Now, I know it sounds like a data engineer's pipe dream, right? But it's very real, and it's happening right now. Here is how we're breaking it down today. First, the data paradigm shift. Second, DuckDB as the core engine. Third, the Duck Lake storage layer. Fourth, Mother Duck in the cloud. Fifth, a comparison with legacy formats. And finally, why this entire stack matters. Let's jump right in. Section 1, the data paradigm shift. Moving away from the heavy clusters of the past decade. For well over 10 years now, big data analytics essentially forced us into a corner. We were locked into managing these incredibly resource-intensive distributed compute clusters, think Apache Spark or massive cloud warehouses like Snowflake, regardless of our actual data size. That was the old way. And let's be real. Anyone who has spent their weekend nursing an unhealthy Spark cluster back to life knows it required exhausting orchestration. But thankfully, we are finally moving toward the new way, the Duck Stack. It's a lightweight, highly composable, and hyper-efficient alternative that relies on embedded columnar processing combined with hybrid cloud compute. Basically, it's about using exactly what you need, exactly when you need it. Moving on to Section 2, DuckDB, the core engine and our foundational building block. Let's start small, right on your local machine, with the absolute base of the entire stack. You've likely heard of SQLite, right? It completely revolutionized transactional workloads by embedding directly inside applications. Well, DuckDB is often called the SQLite for OLAP. It does the exact same thing, but for analytics. It's an open-source, embedded columnar database engine created by Hannes Mullesen and Mark Rosfeldi, and it was designed specifically to make analytics incredibly fast and surprisingly simple. So how does it actually pull this off? First off, it's completely in process with zero dependencies. It's literally a single binary you can drop into Python, Node.js, or even your web browser using WebAssembly. Under the hood, it uses a vectorized execution engine, processing data using your CPU's SIMD instructions for maximum hardware efficiency. But honestly, the real game changer is out-of-core processing. It seamlessly queries datasets way larger than your RAM by streaming data off the disk. You can finally say goodbye to those dreaded out-of-memory crashes. Combine that with zero-copy data transfer to tools like Pandas and Apache Arrow, plus a highly extensible plugin architecture, and you have an absolute powerhouse living right on your laptop. All right, Section 3, Duck Lake, the storage layer, dedicated to removing lakehouse friction. So, while DuckDB brilliantly solved local execution, managing open storage at scale remained a massive headache. Traditional formats, think Apache Iceberg or Delta Lake, they suffer from the small metadata file problem. They store metadata across thousands of JSON or Avro manifest files. Finding the right files requires sifting through all of this, which slows down query planning immensely and forces your team into constant, tedious background compaction. Not fun. The founders of DuckDB solved this massive headache through strict decoupling. In the data layer, your actual columnar records sit as open Parquet files in cheap object storage, like AWS S3 or Cloudflare R2. But here is the trick. In the metadata layer, table schemas, partitions, and file mappings aren't scattered across S3. No, they are stored securely inside a lightning-fast transactional relational database, like Postgres or Mother Duck's managed catalog. And this decoupling completely changes the game. Metadata lookups take milliseconds now because it's literally just an indexed SQL query. It even introduces this brilliant concept of data inlining for small batch writes, smoothly storing them directly inside the catalog before flushing them into larger Parquet files. That completely eliminates those small file bottlenecks we just talked about. Plus, you get atomic, multi-table ACID transactions across your entire schema, and the whole thing remains engine agnostic through standard SQL. Section 4, Mother Duck, the cloud extension. This is where we scale from the laptop to the enterprise. Let's zoom out to the cloud layer because we need to answer a very important question. How do you scale this up for an entire enterprise? Enter Mother Duck. Mother Duck is a serverless, cloud-native enterprise platform built entirely around DuckDB and Duck Lake. Fun fact, it was actually co-founded by Jordan Tigani, a founding engineer of Google BigQuery, which tells you a lot about its pedigree. It wraps all this incredible local power together without losing the simplicity of your local DuckDB experience. The absolute crown jewel here is hybrid query execution. MotherDuck intelligently splits the compute. It runs small filtering and local joins right on your laptop, but then seamlessly pushes massive aggregate scans to the cloud, where the heavy data lives. It gives you fully managed Duck Lake catalogs, letting you spin up a petabyte-scale lakehouse with zero ops, and you can even bring your own bucket for private storage. And incredibly, it features native Model Context Protocol servers, meaning your AI assistants can query your warehouse directly using natural language. It's incredibly forward-thinking. Section 5, Duck Lake versus legacy formats. Let's look at the head-to-head comparison. When you put Duck Lake next to Apache Iceberg or Delta Lake side by side, the contrast is actually pretty stark. Where Iceberg and Delta require scanning file trees and JSON logs, Duck Lake uses a relational database for sub-10 millisecond lookups. Where the legacy formats require constant background compaction for small files, Duck Lake uses clever data inlining. Duck Lake supports native multi-table transactions, which the others simply don't. And perhaps most importantly for your engineering teams, Duck Lake requires absolutely zero setup complexity compared to the high hurdles of legacy catalog servers. Section 6. Why this stack matters. Unifying the local developer experience with cloud-scale capabilities. Let's bring this all together and look at the real-world impact of adopting this end-to-end architecture. The entire ecosystem is so elegantly composed. For ingestion, you have tools like lightning-fast dbt DuckDB and stream pipelines via Streamcape. For storage, your data rests in universally readable OpenParquet files on cheap object storage, perfectly organized by Duck Lake. For compute, you leverage the magic of hybrid local DuckDB and MotherDuck Scale. And finally, for serving, you effortlessly connect fast BI tools like Rill or Evidence.dev and integrate AI agents seamlessly. It is a complete, well-oiled machine. But here is the number that really gets people's attention: 80%. By eliminating the need for massive, complex cluster orchestration that runs 24/7, organizations adopting this stack can cut their cloud bills by up to 80%. That is a staggering reduction in overhead. And the best part? You aren't sacrificing speed to get those savings. You still get sub-second query performance for 99% of your analytical workloads. It represents a pragmatic shift back to simplicity. You get the speed, you get the scale, but without the massive burden of managing a single traditional server. Which leaves us with one massive, provocative question to consider for the future of our data architecture. Does the rapid rise and sheer efficiency of the Duck stack mean the era of massive distributed big data clusters is finally coming to an end? Because when you can process petabytes this quickly and cheaply, the heavy orchestration of the past decade suddenly looks very, very outdated. It's definitely something to chew on as you plan your next data project. Thank you so much for joining me on this explainer, and keep exploring.